Yo, what's up everyone? Welcome back to Yahazek React, the channel where I was forced to tie my hair because otherwise I keep playing with it instead of watching the video that I'm supposed to be reacting to, and it was really f***ing annoying. And today we're watching a video by Soup Emporium called Yellowstone Won't Explode and End Civilization, in brackets, sorry, the deep dive. Obviously, really disappointing stuff because we all want to see Civilization, and I mean Yellowstone, the big volcano, that's all I know. All I know is the Yellowstone is a big volcano that was... Who the fuck? You know, we'll find out today. Well, what's the point of guessing here? Let's just start watching the video. Yeah, I have no idea. Is it going to be funny? What is... Literally no context for this guy. I have never seen one of his videos before, so... I'm just curious. I don't know much about volcanoes, so I probably won't have too much to add to the video. So this is the first time I'm doing an actual a video that's more of a reaction, because you know normally I had kind of discussion videos.
New video time to new video time to spin the content wheel.
I'm still dying.
Yes, volcano chat. Yellowstone won't explode and end civilization. Wait, what? Yes, it will. That's what everyone says about Yellowstone. We're all sitting on a civilization-ending ticking time.
Right, of course.
Yellowstone is overdue for a super eruption.
Yeah, that's why people live there. Naturally, because otherwise, I mean, why would you live there if there wasn't a threat? Like, I mean, people live there for the risk factor, right?
It gets thousands of earthquakes a year. It's filling up with magma. It's only a matter of time before it goes. And when Yellowstone goes, it'll be Armageddon.
Fuck yeah. This is what we want. I've actually seen this video, like the thumbnail for the video.
Yeah,
a
I know
little
that's
guy
what everyone says, but
poking a little hole show up on my timeline like a billion times, and every time I saw it, well, like recently, I'm like, man, I really want to go watch this video, but I gotta save it for the reaction. Because I was sick.
Put on your pajamas
and now we're
and
watching
make yourself a sleepy tea, because it's time to get into our debunk beds. Your ex-girlfriend wasn't lying when she said you weren't. Just get in the bed.
I'm very disappointed. Alright, I'm loving this already.
But Yellowstone is a ticking time bomb. It could erupt tomorrow. I mean, it could, but it's not likely. Yellowstone is one of the most well-watched volcanoes on the planet. I'm talking GPS, LiDAR, seismic stations, field monitor.
So what you're saying is if a massive fucking planetary sized disaster was to happen, we would kind of know about it? What? Huh? We'd be aware before it happens?
Monitoring ankle bracelets. If Yellowstone were about to explode, we'd be seeing a lot more activity on it. I'm talking magnitude-5 earthquake swarms, meters of uplift a year, explosions from geothermal reservoirs, curfew breaking. We don't really see any of that. And since these precursors to eruptions typically take days to weeks before an actual eruption, it's safe to assume that one's not on the horizon, and we'll get plenty of warning if that ever changes. I mean, don't you think the army of volcanologists who dedicate their lives to monitoring the Yellowstone caldera system would have alerted everyone to an existential crisis if it were just around the corner? But isn't Yellowstone always uplifting? Is that a sign of magma, accumulation, and an impending...
Sorry, we need that. I want that infographic. Isn't always uplifting. I don't actually know what uplifting means.
Of magma?
A Patreon pointed out I said magna and I couldn't unhear it. Oh wait, shit.
Around the corner? But isn't Yellowstone always uplifting? Isn't that a sign of magma accumulation?
No, I said
and
magma.
Impending explosive eruption? No.
Oh, in the edit, right.
Yellowstone's moved a lot over its history. We can go all the way back to the end of the last glacial maximum.
Yeah, but all rocks move, like all mountains and shit.
Terraces along the northern part of Lake Yellowstone at Mary Bay. Ray, little bake-off joke for you there. These terraces at Mary Bay were formed by water erosion, and the fact that we see so many of these terraces suggests that Yellowstone Lake has risen and fallen historically. Since the lake is closed off from other large bodies of water, we know the lake levels are due to subsidence and uplift. We can date these terraces using archaeological evidence and tetrachronology, dating things by looking at my Australian, ash deposits from the past eruptions, and determine that since the end of the last ice age, Yellowstone has subsided by 100 foot, or 30 meters in sensible units. Yellowstone still has these patterns of uplift and subsidence, subsidence. Remember when I said Yellowstone is one of the most well-watched volcanoes on Earth? Of course you do. It was less than a minute ago. A leveling survey done in 1923...
Yeah, no, he is vastly overestimating our attention span. Also, I want to see that little screenshot from Premiere or whatever the app he was using. What is this? What was that? What kind of silly app is this? What is this silly video maker? Also, we're watching in 480p for some reason. Yeah, what is this silly DaVinci Resolve?
A leveling survey done in 1923 and repeated in the mid-1900s on Earth? Of course you do. It was less than...
Yeah, Jesus. Is this for animations? I wonder. Probably, because, yeah. Yeah, I'm assuming.
A leveling survey done in 1923 and repeated in the mid-1970s suggests that ground at Yellowstone has uplifted by a maximum of 72 centimeters in the last 50 years between surveys, a rate of about 1.4 centimeters a year.
So nothing's going on,
yep.
yep.
We can see that the northernmost point of the caldera had marked uplift between 2004 and 2009, and then it gradually subsided, and then another bit of uplift between 2014 and 2015 occurred, and since then the northern point of the caldera has been subsiding. We can see the same thing around Old Faithful, uplift and subsidence, up and down, about 1 or 2 centimeters a year, or an inch in American units. This is quite normal in Yellowstone. The amount it's currently moving is consistent with historical norms. An inch a year is still quite impressive. That's not what your mom thinks. Oh!
Yeah. Okay. Literally makes no sense.
The movement is impressive, but the inch or so a year Yellowstone moves pales in comparison to Campy Fleg.
And I've never heard of that one, so...
It's pronounced
Campi Flegrei.
Oh, Google Translate, I love you.
I think
Hey, that's how I would have
just
pronounced it.
friends.
I meant it more in the Platonic.
Up in AWA.
Leveling surveys started at
Campi Flegrei.
in 1905 and were repeated frequently to assess how the ground moved, since deformation was a well-known phenomena in the region. Between 1905 and 1950, the caldera subsided by over a meter. Then several episodes of uplift occurred. The largest were between 1969 and 1972 and 1982 to 1984, where the ground rose by 1.75 meters during each episode. When you plot the vertical deformation
Yeah, it sounds pretty bad.
Flegrei.
at the same scale as that of Long Valley and Yellowstone,
That's so
the
jarring
lines of
whenever he puts the fucking Google Translate TTS.
the caldera
Especially because we have good TTS things now. You don't have to keep using Google Translate. There's fucking AI that will pronounce it like the perfect Italian, I bet. Hey, I mean, this is funnier though. Oh, and plus the videos from 11 months ago, so the AI boom wasn't quite there yet.
in the USA look almost flat. But wait, there's more! Near the center of the caldera is a 2,000-year-old Roman ruin that has 3 columns, all of which have evidence of mollusk borings several meters above their bases.
What does that mean?
The columns were above sea level now, and they were built above sea level. Obviously, the Romans weren't sea people. But between the time they were built and now, the ground subsided below sea level by several meters, and then rose out of the
Alright,
sea
that makes
level
sense, that
again.
makes
It was
sense.
the study of this site
Yeah, I like that he had to specify that it was built above sea level. I mean, hey, you never know with the Romans, am I right, guys?
in the 1820s that convinced geologists that the ground at volcanoes could move up and down by dramatic amounts due to subsurface magmatic activity. Right, so Yellowstone's uplift and subsidence is caused by magma then? No. Let's cut this hotspot in half and have a look inside.
Oh.
This is a tomographic P-wave model of the Yellowstone caldera system. Think of it like a CAT scan, but for the Earth. Tomography
kinda
uses
boring,
earthquakes and
guys.
measures bounce back times and wave amplitudes
I want some calamity.
to infer how the material inside the Earth changed the speed and energy of the seismic waves, and thus what the inside of the Earth is made of. In Yellowstone, you have 2 magma mush reservoirs. Now, there isn't time to get into what a mush is. Read this paper. The one at the
No.
top is located in the
I shall not. I believe you. I'll just take his word for it that it's something very cool and interesting that I'm sure I would love reading about but no.
shallow crust, only 5 to 17 kilometers, or about 3 to 10 miles below the Earth's surface, and that provides the heat to fuel Yellowstone's hydrothermal systems of hot springs, mud spots, and geysers.
The
Makes
upper
sense.
magma reservoir is made of a rhyolite melt, a very viscous magma due to its
Alright, so it's okay.
high silica content, and a
Yeah.
less dense kind of magma
But that looks like there's not that much of it.
than other types. Below the rhyolite reservoir, about 20 to 50 kilometers down, is a basaltic reservoir made of a denser, runnier kind of magma.
The formation of these two
Okay, so it's made of magma. That explains it. So this is the little worm thing at the top. This little worm is basically just the what would you call it? The surface or It's
Distinct
the
magmatic
exposed,
components
not
are either
exposed,
from
the more
gradual
exposed
cooling of
part.
this basaltic block, which
Still in
created
the
a
ground,
rhyolite,
technically,
which
but-
then separated out into the less dense rhyolite chamber, or
Yep.
melting of the country rock due to the heat provided by the basalt made the rhyolite chamber. And in the caldera system,
Oh,
we
and
don't
you
see
won't
any
know. Okay,
basaltic
that makes
lavas.
sense. That makes
All the
sense.
basalt lavas in the region surround the caldera, but within the caldera
won't know.
system, there's no
They don't know.
basaltic lavas at all. This lack of basalt is actually pretty good evidence that the rhyolite chamber is still molten, and the two distinct chambers actually explains why we don't see basaltic eruptions in the caldera like in other hotspot volcanic systems like Hawaii, because the higher density basalt can't break through the lower density rhyolite Sorry, I
Oh.
got distracted there. Volcanoes erupt when there's a sufficient amount of available
I had no
magma
idea.
below the surface. And a
Dad,
sufficient
this is
amount-
such a weird thing to learn about. Like, I'm gonna, like, some 7 years worth of reaction videos down the line, I'll be talking about something, and then I'll be like, by the way, guys, it's gonna be like very mildly on topic, and I'll use it to flex my knowledge, or I'll be fucking with my grandparents at the Christmas dinner table or whatever. I'll be like, yeah, grandma, by the way, did you know? Just hit her with the
amount of
volcano
pressure to force
facts.
it to the surface. We know, based on tomographic data, that the rhyolite melt is only 5 to 15% molten, and that the basaltic melt below it is only 2% molten.
What the I thought this was I thought this was supposed to be like completely just pure liquid.
Even though the rhyolite melt is partially molten, the Yellowstone caldera doesn't have enough magma in the system to cause a large eruption.
That's kinda
The main
boring.
magma bodies are too frozen. Magma typically doesn't erupt unless it has more than 50% melt. The amount Yellowstone is moving up and down suggests it's not magma accumulation driving these cycles of uplift and subsidence. It's more likely to be hydrothermal fluids like gases and water. But
What the
Yellowstone gets a lot of
fuck?
earthquakes. Aren't they signs of magma accumulation? So Yellowstone does get a lot of earthquakes, and about half of them occur in swarms along these bands. Last year,
Okay,
Yellowstone got over
looks interesting.
2,000 earthquakes, but most of those were magnitude 2 or smaller, and they're not really felt by anyone. And they're not driven by magma buildup either. We can actually figure out if an earthquake is caused by the movement of magma or subsurface
Yeah, that's what
water,
I
because
want to know.
each driver has unique
By magma
If
or
an
by what?
earthquake is caused by the movement of magma or subsurface water, because each driver has
Okay, by the way, I want to keep the captions on, but my camera cover them, and if I do this, it's kind of annoying. So for a little while, we'll go no captions. Maybe if I end up ever cutting my camera like on both sides and doing, you know, a little bit of this or whatever.
has unique characteristics. While water can travel through very small pre-existing cracks or faults within the crust, magma requires a much thicker crack to allow the magma to push through without cooling and solidifying. So
Yep, that
water
makes sense.
earthquakes will migrate upwards and laterally across space and time.
And that's
Because
why
magma
water causes
needs a
okay
thick crack to push
more
through.
earthquakes.
We usually see surface deformation as well, you know, because the rocks are being pushed up. That typically doesn't happen with water. Also, earthquakes triggered by water will usually occur as fault slips on faults which the fluids are moving through. So the two sides of the crack hosting the fluid are still in contact with each other, but the fluid reduces the clamping forces and lubricates the fault enough to allow it to slip. In
Yeah.
contrast, the walls of a crack hosting magma are generally not in direct contact with each other. They're separated by the magma itself. So rather than occurring by a slip between the walls of the crack, earthquakes will instead occur near the crack tip, the point ahead of the magma where the crack is starting to open, or off to the sides of the crack because the opening of the rock stresses the surrounding rocks. So if it's
So what you're saying is we're not forming any cracks and there's no magma moving because all the magma is most likely probably frozen and it's just a chill volcano that's gonna exist. Man, what the
a
fuck?
water-driven fault slip, then the earthquakes will repeatedly occur on the same small sticky patches
boring.
within already present faults, and the migration will be fast because it's not forcing the rock apart. Let's have a look at the 2017 Maple Creek earthquake swarm. In June of 2017, an earthquake swarm began beneath the western edge of the Yellowstone National Park, and it lasted about 3 months. From a geological perspective, this swarm was really good for figuring out what's going on beneath the surface of
Makes
Yellowstone
sense.
because it produced thousands of earthquakes. This graph is plotting earthquakes from the Maple Creek swarm by time, depth, and location. A lot of the
That is
earthquakes
wild
are parallel and
that they can do
oriented along
depth.
the east-northeast trend, but some earthquakes also occurred on faults with orientations that are nearly perpendicular to that trend. Over the 3 months of the swarm, you can see that the earthquakes migrated outwards from their initial activation area, both laterally and in depth. Sometimes this was a fast migration, and other times it was slow, and we didn't see large deformation of the surface.
Right, now explain what this all shit means to us plebs who have no idea about what topic even is this? Is this, I mean, the general, like how do you round all of this? Because is it just the study of volcanoes? But nah, earthquakes and shit. I mean, we learned anything related to this. We learned in geography, but I feel like that's way too broad. There's gonna be a slightly more specific term for it. I don't know. Someone in the comments, if you could enlighten me, that would be great.
Time as the earthquake swarm. The mix of colors
I'll
at the
pin
same
it.
latitude and depth also suggests that the same faults are being reactivated. This kind of pattern isn't indicative of magma. They're likely being driven by the release of heated water in the deep crust. Almost all
Oh,
earthquakes
okay.
at
So
Yellowstone are
as
brittle
explained, yeah, it's just water.
failure events caused when rocks break due to crustal stresses, usually from hot water interacting with the cooler, brittle surface rocks, stressed from the fact they go up and down more than your mom does. Oh, sorry.
All right, that
I'll
was.
stop those now.
No, that was fine. That one was pretty good.
No, sorry, I don't buy this. Yellowstone has a history of super eruptions. It's called a super volcano for a reason. Just because it's quiet now doesn't mean it's not overdue for a civilization-ending eruption.
Hell yeah.
Okay, well, first off, Yellowstone isn't a super volcano. Yeah, Yellowstone is one of the largest caldera systems on the planet, but the term super volcano isn't a widely used term academically.
What does it even mean?
One of its first documented uses was in a review of a book by volcanologist Howell Williams in the mid-1940s called
The Ancient Volcanoes of Oregon.
Williams was challenging the idea that the three sister volcanic system was a super system. He thought they were three separate volcanic systems.
In 20, sorry, my tripod with the phone kind of covers the top left, so I have to. In 1924, Hodge performed fieldwork around the Three Sisters area, I'm guessing, and concluded that the three adjacent volcanoes and their foothills were once a part of a single giant volcano. Oh, and that's why he called it a supervolcano. So all it means is a conglomeration of a few smaller ones, not necessarily a gigavolcano. Actually, it didn't say that in the text. That's just my assumption.
In Williams' book, F.M. Byers Jr. refers to Mount Multnomah as a supervolcano, not Yellowstone. But he wasn't using supervolcano scientifically, because it's not a scientific term.
Yeah,
the
it just
term
kind of...
supervolcano only really caught on in popular culture when the BBC's Horizon program stuck the term onto Yellowstone, and then some other documentaries ran with it. And it's a misleading
So it was
term.
literally
It
just
is.
made up on the spot, not even by scientists. I mean, the documentary guys could be scientists, but that's not the purpose of the word.
Supervolcano.
It just exists to make it sound more grand.
Think.
If a supervolcano were to erupt, would it take us back to the Ice Age? Wipe out half the global population? Push humanity to the brink of extinction?
Yeah, remember when Discovery Channel did real documentaries? Because I don't. Supervolcano implies that the volcanic system only produces super eruptions, but Yellowstone and other large volcanoes...
Wait, was that a diss on Discovery? I think I caught a subtle, not very subtle actually, diss on Discovery.
have lots of different...
To be fair, it's been so long since I've watched that channel or much of anything on it at all. I wonder how much misinformation I absorbed.
eruption styles.
If any.
Higher in Guatemala has the potential to produce a super
Or maybe a
colossal
ton.
eruption
You
in the
never
next millennia, but when I climbed up it was just producing effusive lavas. Another volcano I climbed up in Guatemala, Santa Maria, has a history of
Pre-cum.
colossal eruptions, but the massive deciduous
pre-eruption.
Santiaguito dome attached to it has very regular eruptive patterns. Transitions from effusive to explosive activity and vice versa can be rapid, but all this says is volcanic systems are dynamic. Yellowstone's eruption isn't guaranteed to be a super eruption. Now, Yellowstone does have a history
Wait, so even if Yellowstone does decide to go sicko mode, it's not necessarily going to be anything
of
crazy?
super eruptions which are
What
an
the
8 on the volcanic
fuck?
explosivity index. About 2.1
wait.
million years ago, eruptions which are an
Okay, so the Yellowstone eruption that was super mega big was 10 kilometers or 1,000 kilometers cubed, and that was 600,000 years ago. Okay, I mean, even if Yellowstone does go off, what's the chances that it's going to be within this 100 years or whatever that we're alive? You know, who cares?
8 on the volcanic explosivity.
We're going to be dead
About
before.
2.1 million years ago, an eruption that formed the Yellowstone Huckleberry Ridge tuff
Yeah, we're all going to be dead before this becomes a problem. Which it most likely won't from what I understand from this video so far. But if the eruption does ever become a problem, it will most likely not be this exact century. It'll probably be when we're dead, and it's a problem for our future guys to decide, you know, same as climate changes and global warming and like fuck
produced
everything, all of
2,500
it.
cubic kilometers of material with widespread continental ashfall. About 1.3 million years ago at Henry's Falls, the Yellowstone Mesa Falls tuff, a super eruption generated 280 cubic kilometers of material. And
Oh, is that? Okay,
631,000
I
years
see.
ago, the eruption which formed Yellowstone Lava Creek generated 1,000 cubic kilometers of material. So Yellowstone has had super eruptions before? Yeah. So it's overdue for a super eruption. No.
So is the term super eruption a scientific term, or is that kind of just like super volcano, you know? We just use it to describe a large eruption. Although I guess it doesn't matter in this case because we are still using it to describe something specific.
So it's overdue for a super eruption. No. First off, the most common kind of eruptive activity in Yellowstone are lava flows, and even then they aren't that common. The last one was about 70,000 years ago. The most likely kind of hazardous eruption at Yellowstone, according to the US Geological Survey, is a hydrothermal eruption. Think of a big geyser going off.
Nice and cool, you know what I mean?
But second,
Geyser,
volcanoes
it's
aren't
geyser!
overdue. That's not how volcanoes work. Some volcanoes have cyclical patterns of behavior, but the idea of the Yellowstone caldera system being overdue comes from looking at the time gaps between previous super eruptions.
Yeah, but
The
what if it
idea
just
is
ran out? What if it's just getting cold now and it's just not gonna really go off
These
again? It
super eruptions were
doesn't
all
have to.
separated by 600,000 years or so, and since the last one was 631,000 years ago, we're 31,000 years overdue.
Oh, yeah, that
First,
makes
this is
total
based on
sense,
three
actually.
Data points. It's not a solid assumption. Volcanic systems are unpredictable. You can't use three numbers to get a meaningful statistic on this next eruption.
Yeah.
And the intervals aren't even 600,000 years apart. 2.1 million minus 1.3 million equals 800,000. 1.3
Yeah, what the
million
fuck?
minus 631,000 is 669,000. 800,000 plus 669,000 is 1.469 million. Divide that by 2 means 734,500 years between eruptions, which means the average time between massive
Yeah, on
eruptions
average, we
isn't
should
even
expect
close
to even-
600,000 years. So
should
Yellowstone
even
isn't
exp-
overdue at all by those numbers. Most volcanic systems don't have
Shit is
multiple
so
big eruptive
stupid.
events. When they do, the
This is
super
so
eruptions
dumb.
aren't evenly spaced in
So the whole Yellowstone shit really just is all a bunch of nothing, mate. And the only ones talking about it are those uneducated or channels that are planning to, or like news and whatever the fuck that like to make people panic a little bit for profit.
time. And 3, just to complicate things, Yellowstone is a hotspot volcano. Most volcanoes
That looks
form
so
around
cool, by the
zones of
way.
tectonic activity.
This exact fucking that
Yellowstone
looks
is a
so
hotspot
sick.
volcano. Most volcanoes form around zones of tectonic activity where the plates either move apart or get subducted under each other. The most prominent area of volcanic activity on Earth is the Pacific Ring of Fire. Hotspots, by contrast, are zones of melting that are relatively stationary on the Earth.
It was
where the
a
volcano
reference.
forms around a convecting mantle plume while the plate above it moves. This is how the island chain of Hawaii formed. The island arc is evidence of the
Right.
Pacific plate that are relatively stationary on the Earth, where the volcano forms around a
Yeah.
convecting mantle plume while the plate
Yeah.
above it moves. This is how the island
Wait, so what about the thing moving?
volcano forms around a convecting mantle plume while the plate above it moves.
Oh, and then okay,
This is how the
yeah,
island
that
chain
makes
of
sense.
Hawaii
I'm
formed.
just
The island arc is
fucking
evidence of the
stupid.
Pacific plate moving relative to the hotspot which formed Hawaii.
I have brain
Same
fog.
principle applies to Yellowstone. The movement of the North American tectonic plate creates a chain of calderas. We can't see the calderas anymore because of erosion.
As in the infinite. It's just the thing you get when you're on the internet. Really, you shouldn't think about it too much. Go watch some more videos instead. Really, just don't think at all. Actually, if you're thinking too hard, go watch some shorts. And we're really going off topic now. Let's watch the earthquake video.
Plate creates a chain
Or
of
volcano.
calderas. We can't see
See, the volcano eruption is so irrelevant. I'm calling it the earthquake video. That's how fake this shit is.
the calderas anymore because of erosion and because they get buried beneath younger basaltic lava flows and sediments, like the ones that blanket the Snake River Plain, the location of the last caldera system from this hotspot. But we can trace the hotspot's migration across the states from northern Nevada to
So the actual hotspot moves. I thought it was only the top of it.
Wyoming. If you reconstruct the eruption history across the hotspot's migration to include super eruptions from the past caldera systems, that makes 15 large calderas in 16.5 million years. That makes an average of 1.1 million years between big calderas, so we have even
Super
more
quick.
headroom. Actually, let's go back to the magmatic system beneath Yellowstone caldera driving its eruptions. Remember when I said
It's
that was a
basically
sidetrack?
guaranteed to
I
happen
lied.
tomorrow,
Ha!
actually.
The combination of the moving plate and hotspot creates this conveyor belt of caldera clusters, so we can look at the past caldera systems and compare those to the current petrology in Yellowstone to learn about the cycle of magma production and potential futures for Yellowstone.
Okay.
And there's good evidence to
Let's see
suggest
it.
that Yellowstone could be shutting down. Okay, this one will take some explaining. Water contains two elements,
Yeah, that'd be-
hydrogen and oxygen. With me, so
That would be so... Well, first of all, yeah, probably for the best, but also anticlimactic as fuck.
so far. Oxygen has two distinct isotopes, oxygen-16 and a heavier oxygen-18. Water molecules containing light oxygen evaporate slightly more readily than water molecules containing a heavy oxygen atom. At the same time, water vapor molecules containing the heavy variety of oxygen condense more readily, so they get rained out first. Whether or not water has more oxygen-16 relative to oxygen-18 is temperature dependent, so the concentration of oxygen-18 in precipitation decreases with temperature.
The measure of the ratio between oxygen-16 and oxygen-18 is known as delta O18.
Rocks near the surface acquire hydrogen and oxygen isotope signatures from rainwater, but if there's an intrusion of a hot magmatic body into these rocks, then it initiates groundwater convection by heating groundwater, which cracks wall rocks and allows isotopic exchanges between groundwater and wall rocks. As the intrusion crystallizes and cools, the convecting groundwater system collapses on the intrusion and alters the minerals of the intrusion itself. Over time,
makes sense.
magmas gain an isotopic signature based on this process occurring over and over.
Right, so basically on the floor, the ground is gonna be more saturated with oxygen-18 water rather than oxygen-16 water. Okay.
Zircon crystals retain their isotopic signatures despite episodes of remelting, so we can take oxygen isotope ratios in quartz and zircon and then use them to date the crystals based on oxygen isotope ratios.
Yeah, so the more cycles it's gone through, the more it's gonna have the heavy oxygen,
ratios,
right?
As well as track transient changes in the magmatic system, like fresh injections of magma from the mantle plume. If the zircon crystals have distinct oxygen...
By the way, zircon is such a fucking... There is no way in hell that name exists and you're not supposed to use it as zircon. You know, this is a Ligma joke in there waiting to happen. Like zircon my dick, you know. So.
Isotope ratios. It means that they formed from
Zircon my
isotopically
ligma
distinct
balls.
magma batches that were generated by the recycling of
Zircon.
previously erupted material. Studies of the zircon crystals in Yellowstone reveal that they're between 0.8 and 2.1 million years old, and they are isotopically distinct from one another. When combined with the fact that the rocks they are contained in erupted less than 500,000 years ago, and the fact zircon analysis across the last three calderas shows a decrease in delta oxygen-18 in magmas, and then a gradual recovery towards normal delta oxygen-18 compositions, with the overall trend being a general decrease in delta oxygen-18 values across each caldera's life cycle. This overall decline and gradual recovery points to the recycling and remelting of previously erupted material. Taken together, it suggests that current Yellowstone volcanism is a combination of new magma production and the recycling of already erupted material, which includes lava and tuff. So Yellowstone recycles material, so what? A more powerful hotspot would be continually injecting magmas from deep in the mantle. If Yellowstone is recycling material, it suggests that the future melting potential of the crust is getting exhausted, which implies a decline in major volcanic
In other words, Yellowstone might never go off again just because we had a somewhat consistent period between the explosions previously, or the eruptions. Literally in no way indicates that we're gonna have another one, especially with all this shit. This if anything makes it look like, yeah, it's probably just gonna
Yellowstone because of a combination of its explosive history and landforms created by subsequent viscous rhyolite
die down.
flows. But at Henry's Fork caldera just down the road, it's quite flat, and the reason it's flat is because the caldera got filled in with basaltic magma and was eroded with time. Henry's Fork caldera
That's actually
had
so
a
cool.
similar magmatic
This area looks straight out of super flat Minecraft. That is so sick, man. That's actually something I really wish you could do, like Minecraft did well. A super flat world that had like rivers and shit, and maybe like forests.
Caldera just down
That
the
would be
road is
so
quite
cool.
flat, and the reason it's flat is because the caldera got filled in with basaltic magma and was eroded with time. Henry's Fork caldera had a similar magmatic system to Yellowstone. However, once this upper crustal magma cooled and solidified, basalt magmas could penetrate the upper crust and erupt. These basalts, similar to the ones that erupt in Hawaii, are less viscous than rhyolites, so they fill in topographic lows. So Yellowstone could have another super eruption, or the mantle system feeding Yellowstone's present-day volcanism could wind down. The caldera system could die out, and it would just get filled in with boring basaltic lava like at Henry's Fork caldera. Right, so what I'm hearing from all this is that Yellowstone could explode and wipe out all civilization.
It could.
There have been larger eruptions than Yellowstone in human history, which
No, what?
did not end all civilization, or even the human species. The Toba eruption, 74,000 years ago, ejected 5,300 cubic kilometers of dense rock equivalent
the
material, and may
fuck
or may
that
not,
is?
likely not, have caused a human bottleneck. But an eruption more than double the size of Yellowstone's last eruption did not kill us off. Also, they didn't have the benefit of technology back then. The ashfall wouldn't necessarily be cataclysmic from a Yellowstone super eruption either. The problem with figuring out how far ash from past eruptions would spread is that ash deposits are eroded and rapidly redistributed by
Yeah,
rain,
yeah, that makes
rivers,
sense.
and
It's a
wind.
fucking
So very
ash.
thin deposits far away from the volcanic source are not preserved in the geological record. And this lack of reliable data leaves the door open for liars to write volcano fanfiction on TikTok. Like these guys.
Yeah,
First off,
actually,
as soon as it
fact.
erupted, tens of millions of people within 1,000 miles of the eruption would instantly die. My source is that I made it.
Instantly. What the fuck? They just instantly.
On TikTok. Like these guys.
First off, as soon as it erupted, tens of millions of people within 1,000 miles of the eruption would instantly die.
That is wild. I have no
A
idea.
super eruption would produce a lot of ash, but it wouldn't be a doomsday scenario. Depending on when Yellowstone erupted, even a month-long eruption wouldn't necessarily cover the whole US. And even if it did, the East Coast would maybe get a millimeter or two of ash fall, less
Yeah,
for
who
a week
cares?
and 3 days. And if the eruption didn't make an umbrella plume, even less of the US would be covered in ash. It's worth stressing any of these scenarios would be bad. A few millimeters of ash can reduce traction on roads and runways. It can short out electrical
I mean, of
transformers
course,
and
no,
cause
yeah, it wouldn't be good. Shit. Yeah, no. I could 100% see some ash being bad, but it's not like we're all gonna die because of it. Some will die. Some dudes that just got really unlucky to be in the wrong spot at the wrong time, but
respiratory problems. A few centimeters can cripple agricultural production. Salt Lake City would be
I
buried
guess
under
that's
thousands
bad.
of tons of
That's kinda
architectural
bad, yeah.
improvements. But even the worst case scenarios wouldn't be world-ending. One thing a Yellowstone eruption
Exactly, it would just be-
do is alter the climate.
it would be like a mini cataclysm.
When Pinatubo, a stratovolcano in the Philippines, erupted in 1991, it had a VEI of 6.
It would be
and
the perfect opportunity to start selling face masks again. I'll tell you that much.
ejected nearly 20 million tons of sulfur into the stratosphere. Dispersal of this gas cloud around the world, the 1991 eruption of Pinatubo was about 100 times smaller than Yellowstone's largest known eruption, so it stands to reason that a Yellowstone super eruption would have a bigger impact on the climate. Foraminifera are shell-based organisms whose shells contain temperature-dependent oxygen.
I like that he still decided to go into the hypothesis. What's it called? Into the supposedly it happened, even though it probably won't happen. But supposedly it does. What would happen?
Isotopes that revealed the sea surface temperatures in which they lived. Based on analysis
The
of
hypothetical.
Foraminifera in the Santa Barbara Basin, the oxygen isotopes in their shells suggested that the 631,000 year ago super eruption cooled the oceans by 3 degrees Celsius. It's hard to simulate the impact of a volcanic super eruption because of knock-on effects an eruption can have on the ocean, atmosphere, chemistry, land surface, vegetation, cryosphere, carbon cycle, etc., etc. But one 2012 study attempted to resolve the impacts of a super eruption using an integrated Earth system model. Mean global changes are a 3.5 to 4.5 degree cooling over 2 years, followed by a quick recovery by year 5, and a slower recovery to normal by
That's
year 20.
fine.
There'd be
That's
a mean
fine.
7 degree cooling over land and a 2 degree cooling over the oceans. The cooling would also encourage sea ice growth and make the planet more reflective, which would reduce the amount of energy received at the surface. So Earth system modeling largely agrees with past eruption climate reconstructions. A Yellowstone
So
super
I swear he has a fucking iPhone alarm going off. Do you guys hear this shit?
Earth system modeling largely agrees with past eruption climate reconstructions.
Yeah, that's an iPhone alarm going off. I was like, am I going crazy? Am I actually going sick? Because I'm like, my phone can be going off. I'm using it to record this video.
A Yellowstone-sized super eruption could cool global temperatures by a few degrees for a few years before they recover. The eruption would also change surface wind patterns and ocean circulation patterns, as well as reduce land vegetation cover. Now, this wouldn't be great. The famous year without summer occurred in 1815 after the Tambora eruption caused a global decline in temperatures of about 0.4 to 0.7 degrees. It resulted in
Yeah, it
mass
sounds
famines
like it could
across
affect,
Asia and Western
fuck
Europe,
up some climate
riots,
shit.
political unrest. It more or less erased 7 years of population growth in Vermont. It inspired
Yeah.
Frankenstein, but as a species, we survived it. To quote from Timrick's paper modeling the climate impacts of the Toba super eruption,
It'd be
temperature
bad,
changes might have created
But it probably
thermal
wouldn't be as bad as which means we
Comfort.
and if we survive, we survive this shit.
Prehistoric humans, but they were unlikely to have been a challenge. And even entertaining this idea misses the far larger point that the evidence points to a caldera system that is winding down, and the most likely volcanic scenario at Yellowstone would be a simple
The
lava
virus.
flow with impacts contained to Yellowstone National Park.
Like, this isn't a joke. Yellowstone isn't even in the top 10 for the most dangerous volcanoes in the United States. It's not even in the top 20. It's ranked 21st on the USGS's volcano threat
And yet it's the most
assessment
popular
I'm
one in terms of not, you know, being
99.9%
scary.
sure that 21st century society, or even way beyond, isn't going to experience an extinction-level Yellowstone super eruption. If it even erupts again, Yellowstone isn't going to explode and end civilization. Aww.
Fuck.
Hey, it's okay. We can find another way to destroy civilization. Right, guys? Oh, yeah.
Yeah,
so-
exactly.
Don't worry about it. Yeah.
World War III, boys.
Hello again. Thanks for watching all the way through, everyone. I hope you liked it. Just to
Thanks.
play something up, I pronounce it geyser, but the Del Boy joke was already in there, and I realized it.
Okay, that's good, that's good. I screamed at him for it because who the fuck calls a geezer?
Create a discontinuity to the joke if I pronounced it in two different ways. I don't actually
Yes.
say geyser is geezer. I'm not a monster. Special thanks
That
to
is
my
good.
patrons whose names and peoples are
That is good. All right. Well, actually, let's listen to his ad reads real
appearing
quick.
on screen now, and an extra special thanks to the patron who drew the Wham-oop as well. It's an amazing drawing. Patrons got to see an earlier rough cut version of this video and gave me a lot of notes to make it a lot better, and they got to see it early as well, which is pretty neato. Also, patrons suggested ideas for jokes, so if there was something
I like
in
the
here that you
Among Us
found
one.
funny, chances are I stole it. If you want to help make these things, and I'm not sure why you would, but if you made it this far, you must implicitly think there is some value in this, then consider subscribing or maybe heading over.
I'm here because I think there's value for you guys, for him and you guys going to this video and hitting up his Patreon, or obviously, if you don't want to do that, you know, go give it a like, a sub, maybe leave a comment. Video pretty bussin'. Pretty bussin'. For real, for real. Alright, this comment makes me want to kill myself. That is exactly what we want to see. I'm liking my own comment. Go hit up his video and like. Oh my god. Just kidding, obviously. All right, great video. Yeah, go hit his channel. Obviously, we're just leeching off of other people's content by reacting to it. So that's the nice thing to do. All right. Hit up my main channel. I make great videos there. In fact, one is in the works right now. It's gonna be really fucking good on one of my favorite video games of all time as well. Alrighty, see ya whenever, probably in 5 minutes, cause right after I'm done with this one, I'm starting the next one right away. Alright, bye.